Greetings, ladies and gents, and welcome back at Mike Math and Science Club. Today we'll be looking at the present value annuity. Now, remember, we are still under the financial maths topic. So, remember, in the last sessions that on the last videos, rather. So, I mentioned that we have two types of annuities that you are going to encounter in grade 12. So, you have the future value annuity and of course the present value annuities too. So those are the two annuities that you're going to encounter in grade 12. Now remember, we said by definition in annuity, so this is a regular fixed amount made over equal time interval. So of course, so the future value annuity, we said that this is when you are trying to build a certain amount of money in the future. So what you do is that you of course pay a regular fixed amount every month or every year, or even semi-annually, or even every quarterly, in this case, to reach that goal. So this is when of course the amount that you want is in the future. So that's what we say, that's what the future value annuity is in this case. So again, to go back to this idea of an annuity, so we said an annuity is a regular fixed amount made over equal time interval. So it could be per month or per year or even semi-annually. So now remember, we said that it is a regular fixed amount made over equal time interval, right? So in this case, an annuity alone, it could be, of course, a certain amount that you pay, in a certain account to reach a certain goal, or it could be, it could be an investment. So that's what I'm trying to say. Or also it could be, a certain amount that you have that you're trying to decrease in this case. So again, it could be pension fund or a loan. So that's of course for the annuity definition alone. So when it comes to the present value annuity, now remember we said the future value annuity, this is when you have a certain amount of money in the future, right? So that's what we say, that's the future value, that's what the future value annuity is. But when it comes to the present value annuity, this is of course when we have the amount right now. So this is when of course you have a certain amount right now in the present. So what you're trying to do is that you're trying to decrease that amount as time goes by. So it could be a loan that you were granted, and then what you do is that you try, you pay equal amounts, let's say every month or every year, in order to decrease that amount of money that of course you borrowed. Or it could even be a pension payout in that case. So suppose a pension payout, of course, in this case, when a pension payouts. So in this case, so what you would do is that, of course, instead of taking all of that amount of money, what you would want to do in this case is to get a certain amount of money every month from that pension. So that's of course, so when it comes to the present value annuity, this is when of course we have that amount right now in the present, not in the future. So it could be a loan or a pension payout. So it could be of course a loan, or it could even be a pension payout. So that's of course for the present value annuity. So it could be a loan. Now remember, we said it must be in the present, right? So it could be a loan or even a pension payout. Now suppose we granted a certain amount of loan. So let me just making an example with that. Now suppose they granted us a certain amount of money, a loan. And then they say that what you need to do is that you need to pay 3 payments in order to pay this loan. Now suppose they don't tell us that how much did they grant us, but in this case they just say, now suppose, let's say you are buying a phone, and then they say that what you do is that I'm gonna grant you a loan, so I'm gonna buy this cell phone for you, but what you do, you pay 2,000 every year. So in this case, so if you made 3 payments, in this case you'd be able to pay off the debt. So in this case, so this is when you don't know how much, of course, of the loan you were granted. So now suppose, so they say that you make, of course, 3 payments. So this would be Of course, now remember, when you take a loan, you would actually need to pay at the end of the first month, or if it's monthly, or at the end of the first year if it's yearly, or even first quarter if it's quarterly. So this is would be when, of course, you are granted that loan at T0. So I'm gonna call that amount P. Now, suppose they say that you need to pay 2,000 every, let's say every year. So this would be, so a T1 would pay 2,000, and then a T2 you pay another 2,000. Now remember, with an annuity, this has to be a regular fixed amount, so you must pay the same amount. So again, now they say at T3 we pay another 2,000, and then they say that your loan is finalized. So in this case, so of course, to find out the amount of loan that we they granted us, what you cannot do, remember I mentioned this, that you can't take those three amounts and say that's 2,000, so it would be 2,000, 4,000, and 6,000. So in this case, they granted me a loan of 6,000. So it actually doesn't work in that way. And then the reason why it doesn't work in that way, now remember we said that you cannot add or subtract money unless if you know how much it is worth at the same time. Right? Now suppose they say that this of course loan is granted at at 15% per annum, compounded annually. So in this case, so now suppose they say that we are paying yearly payments. So again, so to find out how much of the loan they granted you, what you need to do is that what you are going to do, you are kind of going to undo the interest. So what you're going to do is that you are going to try to find out how much this 2,000 would be worth at T0, because I'm trying to find out how much of the loan I was granted, right? So in this case, I would try to find out how much would that 2,000 be at T0 at the beginning, and I would actually do the same with that 2,000, the one that is at T2. I would find out how much it is worth at that particular moment. So I would do even the same thing for that T1. So if I know how much how much those 2,000 is worth at T0, so in this case I will know actually how much of the loan was I granted in this case. So what I'm going to do, I'm just going to try to find out how much of this or how much all of this payment are worth at T0. So in this case, I'm going to add them up, and then I'll be able to know how much the loan was, or the amount of the loan in this case. So what I'm going to do is that I'm going to treat each of these amounts separately. So the first thing I'm going to do, I'm going to take that 2,000. I'm going to do things a little bit different, and it's fine if you do not understand this. It's not really that important, but the reason why I'm doing it is because I'm trying to lead you to somewhere. So in this case, what I'm going to do is that I'm gonna pretend that I invested a certain amount of money at T0, and then at the end I get 2,000. So what I'm going to do for that first at the one at T3, so that's for the one at T3, the amount at T3. So what I'm going to do, I'm going to pretend as if it's I made a once of investment, and then at the end of 3 years I get 2,000. So at the end, so I'm going to use the compound interest formula. So now suppose they say that you get 2,000 at the end of 3 years, but in this case you don't know how much of the money that you must invest for you to get that 2,000 there. So in this case, I'm just gonna call that amount K. So in this case, I would need to invest K amount of money at an interest of 15%. So this would be 1 plus 0.15 in this case for 3 years, right? So to find out the amount that I actually deposited into the account for me to get 2,000 at the end of 3 years. So what I will need to do in this case is just to divide by, of course, this bracket here. So in this case, to get K, this would be actually 2,000 divided by, of course, 1 plus 0.15, and of course to the power 3. So of course, if I write this in a nice way, so this would be K would be equals to 2,000 1 plus 0.15 to the power negative 3. So what I did, I just took this denominator, and I kind of put it to the top. So remember, when it goes to the top, the laws of exponents. So since it was positive 3, so what it will do, that it will become a negative 3. So in this case, so what I'm trying to do is I'm trying to find out how much must I invest in this case for me to get 2000 at the end. But if of course I earn 15% per annum compounded as annually, so this would be of course the amount that that 2000 would be worth at of course a T0, and then I'm gonna do the same thing with the one at T2. So in this case, I don't know, I must, so at the end I would need to have 2000, but I don't know how much I must invest, but I'm just gonna call that B. But in this case, at an interest of 15%, so this would be 1 plus 0.15 in this case, but in this case for 2 years, right? So it was in the account for 2 years, so it earned interest for 2 years. So in this case, so this would be actually to the power 2. So to get B, in this case, so P would actually be equals to 2000 divided by, of course, so this would be 1 plus 0.15 to the power 2. Again, so if I write that in, of course, resembling that, so this would be actually equals to 2000, 1 plus 0.15, this case to the power negative 2. So again, I'm gonna do the same thing with that, the one at T1. So again, what I'm gonna try to do is that I'm gonna try to find out. So at the end, of course, I need to have 2000, right? So in this case, I don't know how much I must invest for me, of course, to have that certain amount. So what I'm gonna do, so I must have 2000 at the end, but I don't know how much I must invest for me to get that 2000. I'm gonna just call that A, small letter A. So this would be 1 plus 0.15 to the power 1 in this case. For that would be in the account for 1 year. So in this case, so to get A alone, again, I'm just gonna it is gonna lead to the same point, but in this case, A would actually be equals to 2000, 1 plus 0.15, but in this case, to the power negative 1. So of course, so if I find out how much of all of these amounts are worth at T0, I would know the amount of the loan which I was granted in this case. So of course, so the value of P, so that amount, so that loan there would actually be equal to all of those payments, with all of those payments, of course, in this case, but with all of the interest undone in this case. So I'm kind of moving my money, the amount in this case, to T0. So to find out how much all of those amounts are worth at that particular time. So in this case, I would take the first one, which was actually 2000, 1 plus 0.15, but in this case, to the power negative 3, plus the second, which was 2000, 1 plus 0.15, but in this case, to the power negative 2, plus the second, which was 2000, 1 plus 0.15, but in this case, so that would be to the power negative 1. So in this case, so all of these amounts with all of the interest undone would be equal to that loan there at T0, right? So in this case, I would be able to know how much of the loan that was granted. So in this case, so if you put all of that amounts in your calculator, what you're going to get, 4,000. 566 rand and also 45 cents. So that would be the loan that of course you'll be granted at at the beginning, in order of course for you, if you of course you make those 3 payments of 2000. So in this case, you be of course be paying a loan of 4,466 rand and 45 cents. So this would be of course the loan that you'd be granted in this case, so that particular T0. So you can already see that of course you would end up paying more. Of course you can see that of course if you add all of those amounts, so this would be 2000, so this would be 6,000 in this case. So you were granted 4,000, but at the end you can actually end up paying 6,000. So this is this would actually include even the the interest that each amount and. So in this case, so what would happen is that of course, so you will be granted that loan at that particular time, right? So you would actually pay at T1, right? So what they would do is that they would take that loan, they will move it at T1, and then of course, now remember, so if they move it from that point, of course it would earn interest, right? So in this case, so when it gets to that point, it will no longer be 4,566 and 45 cents. It will actually earn interest. So what they will do, they'll subtract that amount, and then they'll take that same amount that is left, that balance that is left, then they'll move it, of course, until T2. So again, it would earn another interest, and then they subtract that 2000, and then whatever that is left, of course, they would move it until, of course, a T3, and then, of course, they subtract that 2000. So this is actually the reason why you would end up paying more is because of interest. So of course, what I'm going to do, I'm going to show you something which is actually the formula for the present value annuity, and of course I'm going to use this same logic that I used here. So what I'm going to do now, suppose again we were granted a loan of P at the beginning. So this would be a T0, T1, 2. So now suppose they say that you need to make n payments, number of payments. So of course the last payment would be n, right? So the payment before that would be actually n minus 1. So this would be n minus 1. Of course that would be n minus 2, and that would be n minus 3. I hope that's visible. And of course, so what now, suppose they say that you would actually be required to pay X amount of money. So again, so this is where we would actually be granted the loan, right? So at the end of that first time period, you would pay an X amount of rent, and again to do the same, and of course until it n. So you'd actually pay n X amount there, and also of course at that point, and at that, and of course, so that would be the last payment that you'll make. And of course there would be other payments that of course you'd make in between. Unfortunately, I'm not going to be able to fit all of that, but of course, so to find out again the amount, the loan that you were granted in this case. So if they say you need to pay n number of payments, of course, of X rand. So in this case, to find out the amount of the loan that you were granted, what you're going to do is that what I'm going to do is that I'm going to to find out how much this X rand at Tn is worth, of course, at that time period at T0. So in this case, I'm going to try to find out how much that amount is worth at T0, right? And then I'm going to do the same thing with that second one. So I'm going to take that amount, I'm going to find out how much it is worth at T0. So in this case, so of course I'm going to do the same thing with that. So I'm going to take that amount and find out how much it is worth at T0, and of course I'll take that one again to find out how much it is worth, and of course all of that amounts that is in between, and of course until I get to this of course a T, the one that is a T2. So again I would take that amount and find out how much it is worth at T0, and of course the one at T1, and I'll do the same with that. So of course when I add all of these amounts at that particular time, I would be able to know the loan that in this case that was granted in a sense. So of course I'm going to apply the same logic that I did to the example. So of course what you need to do, the first thing that you need to do, now remember we said now what you're going to do is that you're going to treat that amount as an investment. Now suppose you invested a certain amount of money, but at the end you need to have X rand, right? So you would actually have X amount of rent. So now suppose we they say that of course we need to get X amount of rand at Tn. So now I'm gonna treat that as an investment. So suppose they say that I'm gonna get an X amount of rand, but I don't know how much I must invest in order for me to get that amount. But now suppose, so that I'm just gonna call that again to be K. Now I don't know that of course I don't know the amount that I must invest, but I must know that, but I know that at the end I'm gonna have of course X rand right now. Suppose of course they say that the interest is actually I. So again, so this would be 1 plus I, but in this case for n number of times, because it was in the account in this case for the n number of times. So again, so of course to get the amount that of course I actually invested at the beginning, to get that amount, so again I'm going to do the same thing. So this K would actually be equals to X 1 plus I, in this case to the power n. So again, if I rewrite that in a more polite way, so this would actually be X would be of course X would be multiplied by 1 plus I, in this case to the power negative n. So again, to find that the one of course it n minus 1, again I'm gonna do the same thing. I'm gonna say of course I need to get X amount of rand, but I don't know how much I must invest. But in this case I know that the interest is I, right? So in this case I'm just gonna code that, even B. I'm gonna code that to be B. So again I must have of course X rand at the end, but I don't know how much I must invest, right? So this would be B, 1 plus I to the power, of course, so in this case it would be n minus 1. So this would be n minus 1. So to get P, so to get the amount that I must invest, in this case for me to get X rand, so I'm going to divide that everything by that bracket. So B would actually be equals to X divided by 1 plus I, in this case the power n minus 1. So if I write that, of course, resembling that, so B would actually be equals to X 1 plus I in this case. So since that was positive, it would become negative. So the one which was negative in this case would become positive. So this would become negative n plus a 1. So again, you would note that of course that the one at T2, it would actually do the same thing. So in this case, so it would actually get to the same point. So I'm just gonna code that C. So in this case, C would actually be equals to X 1 plus I, in this case to the power negative n plus a 2. In that case, of course, the one I'm just gonna neglect that one. I'm gonna go straight to the one at T2. So in this case, so the one at T2 in this case, so this would actually, so I'm just gonna code that even D. So the one at D, so this would D would actually be equals to X 1 plus I, in this case to the power negative 2. So this would be to the power negative 2. And the one at T1, of course, if I find out how much it is worth at T0, so this would be actually, I'm just going to call that E again. So E would be equals to X 1 plus I to the power negative 1. Now remember, there are still those other payments in between. So to find out how much of the loan that was granted in this case, so we just need to add all of those amounts with all of the, of course, all of those amounts in this case at that particular time, in this case with their interest undone. So what I'm going to do is that, of course, I'm going to say P, it would actually be equals to, so the first one we say that's what's going to be, of course, so this would be X 1 plus I, in this case to the power negative n, right? And the second would be, of course, X 1 plus I, in this case to the power negative n plus 1. And then, of course, the third one, so this would be, of course, X 1 plus I negative n plus a 2. And of course there are other amounts, right, that are in between. And of course I'm going to go, of course, to that the one that is a T2. So this would be plus X 1 plus I to the power in this case, so that would be power negative 2. So this would be a negative 2 plus the one at T1. So the one at T1 will be X 1 plus I, in this case to the power negative 1. So if you note, of course, if you note what's happening, of course, on what I wrote there. So of course, so if I add all of those amounts at that particular time, I would be able to know how much the loan was, or the loan which was granted. So in this case, so what I'm going to do, I'm gonna add all of them up. So what you can already know is that those are variables. I can't plug them in the calculator. So if you note that, of course, so this would be the first term. So that would be the second, and that would be the third in this case. So if you note, so if you note that, of course, to move from that term to, of course, the one at T2, so from T1 to T2, what I did is that, so if you note that so T1 in this case was X multiplied by 1 plus I, right, to the power negative n. So of course T2, you can note that we still have X, so this would be X multiplied by 1 plus I, so in this case to the power negative 1 plus 1. So in this case, so if you note what happened to move from T1 to T2, what I did there is that I actually multiplied by 1 plus I. So in this case, so if you note from this point to that, I actually multiply by 1 plus I. So again, if you note from that term to the one to that one, and again you can note that it actually increased by one, right? So from T2 to T3, I must have multiplied by 1 plus I in this case. So that would be, so that's why it became negative n plus 2. So if you note what I'm doing actually to move from one term to the other, I'm actually multiplying by a common ratio, which is actually 1 plus I. So in this case, so we know that R is actually would be 1 plus I. So as you can note that this actually resembles a geometric sequence. So in this case, of course, to find, of course, the sum of all of these amounts, so what I'm going to do, I'm just going to use the geometric sequence formula, the sum of the geometric sequence formula. So in this case, we know that it says Sn is equals to A R to the power n minus 1, and of course all of that is divided by R minus 1. So of course, so we can note that the first term, we said that's x multiplied by 1 plus I to the power negative n, right? So the first term would be x 1 plus I to the power negative n. So of course that would be open bracket. We said R in this case, that's 1 plus I, right? So this would be 1 plus I in this case, so that's multiplied by, of course, now remember how many terms that are we summing? We are summing n terms, right? So in this case, so this would be actually to the power negative, this would be to the power n. So of course I'm just gonna change that to a square bracket, and of course so we would actually have a negative 1, so that would be negative 1, and of course all of that must be divided by R minus 1. But remember that the ratio, we see that's 1 plus I, right? So this would be 1 plus I in this case, so minus a 1. And of course, so if of course you can see, so what I'm going to do, I'm just going to multiply this out. So I'm going to multiply this bracket, which is 1 plus I to the power negative n. I'm going to multiply that by 1 plus I to the power negative to the power n. So of course you can see that's that the bases are the same. So what you do in this case, you need to add the exponents, right? So in this case, we would have x multiplied by, of course, 1 plus I. This case, so we know that we need to add the exponent, right? So in this case, we have that n, so that would be n minus n. Of course, if I multiply that with that negative 1, this would actually be minus, in this case, so this would be minus 1 plus I, it is in this case to the power negative n. So again, this is still divided by that, but again, you can note that that positive 1 and that 1 will cancel, and then in this case I will just be left with I in the denominator. So again, we know that of course if you add those two, n minus n, it gives us a 0, and anything to the power 0 gives us a 1. So in this case, so this would be x, of course, open bracket, so this would actually be of course 1 minus 1 plus I to the power negative n, and of course all of that would be divided by I. So in this case, so that is actually the future, the present value annuity formula that you get on your formula sheet. So this would be actually equals to PV. So that's the formula for the present value annuity. Now, one thing that I need you to note about this formula is that this formula only works when, of course, so one thing that of course you need to note, I'm just going to write that aside there. So of course, so built into this formula is actually the assumption that, you know, the first time period must pass before the first payment is made. So in this case, there's a gap between, of course, the first payment and, of course, on the day that, of course, the loan is granted. Now, suppose you grant a loan and then they say that you pay monthly payments. So in this case, you grant a loan at T0 and then you'll be expected to pay at the end of the first month. So built into this formula, really is the assumption that one time period passes and the first payment is made, and the first payment is made. So that's one thing that you must note with this formula. And of course, what we're going to do right now, we're just going to look at some examples. Now, we don't need to know, of course, to prove this proof of the present value annuity. But what I need you to notice that this X, of course, stands for the equal payments. And in this case, so N would be actually, so N is actually the number of payments. So N is the number of payments, and of course I in this case stands for the interest rate. So that's one thing that I need you to note. So what we're going to do, we're going to look at some examples, of course, using this present value annuity. So this formula that we have just proved. So we're going to do 3 questions that we're going to do. So of course that will actually consolidate today's lesson. So if of course, let me just bring that down. So again, they said that David takes out a bank loan. So immediately we know that this is a loan. So this must be, of course, the present value annuity, because when you take out a loan, so in this case, you'd have that amount right now, right? And then you'd be expected, of course, to pay as time progresses. So this resembles a present value annuity. So they said that David takes out a bank loan in order to pay for his new car. They say he repays the loan by means of monthly payments of 5,500 for a period of 5 years, starting 1 month after the granting of the loan. So now remember, we said that the present value annuity works on the assumption that the first time period must pass before the first payment is made, right? So that's why they said that, of course, he started to make the first payment, of course, after the first month in this case. So they say the interest rate is 21% per annum compounded monthly. They say calculate the purchase price of his new car. So if we know how much the loan is, how much, of course, the amount of the loan that David took, in this case, we would know of course, the price of the car. So what you need to do, so since this is a present value annuity, we are trying to find out how much, we're trying to find out the loan that which was granted to David, right? So in this case, we would actually use the present value annuity because it is a loan. So in this case, P, we say that's equals to X. So this would be, of course, 1 minus 1 plus I, in this case, to the power negative n. So again, so that's all divided by I. So of course, you can know they say that, of course, David will make monthly payments of 5,000 on 5,500, right? So in this case, we know that the X value, the X in this case would be 5,500, and then of course the interest would be at 21% per annum compounded monthly. So in this case, so we know that X would actually be equals to 5,500. So of course the interest in this case, so since it's 21% per annum compounded monthly, so the interest would actually be 0.21, but in this case divide by 12 because it is actually compounded monthly, right? So in this case, what we'll do to that 21% would actually divide it into 12 chunks in a sense. So in this case, so of course they say that of course, so this loan is actually paid over 5-year period starting in 1 month. So in this case, we'll know that the number of payments, so in this case, so in a year, so remember he's making monthly payment, right? So in a year he would need to make 12 payments. So of course in 5 years, so he would actually need to pay 60 payments. So what you would do to that, you just take that 5, you multiply it by 12. Now remember, in a year he would make 12 payments, right? So in 2 years he would make 24. So to find out the number of payments that David will make in 5 years, you just take 12, you multiply that by 5. So what you'd get, you'd actually get 60. So of course we're going to substitute there. So of course we have 5,500 being the monthly payment, and again, so we have 1 minus 1 plus the interest. We say that's 21%, right? But we divide that by 12, so this will be 0.21. Divide that by 12, and again, so that's of course the number of payments. We see that's 60, right? So this will be negative 60. Don't forget that. So of course you close that bracket, and of course you divide everything by the interest, which is 0.21 divided by 12. So in this case, so if you put all of that in your calculator, what you are going to get is that you're going to get a value of the loan being 203,000, and of course 301.92 cents. So this would be, of course, the amount of this would be the loan that David must take in order for him to purchase that new car. So that would be, of course, so that would be the loan that David must take, of course, in order for to pay for that new car, if he must make 5,500 every month over the period of 5 years. So of course, question 2, they said that 25 half yearly payments are made starting 6 months time in order to repay a loan of 100,000. They say that what is the value of each payment if the interest is 14% per annum compounded as half yearly. Now of course we know that this is of course a loan, because this is a loan, so this tells us this is actually of course the present value annuity. So we have this amount right now, so we want to, so what we'll do in order to reduce that, would actually make equal payments, right, in order for us to pay that 100,000 off. So in this case we know that the present value annuity, so in this case we know that P would actually be equals to X. So in that case, so this would be 1 minus 1 plus I to the power negative n, and we close that, and of course we divide all of that by I. Now we know the amount of the loan, so in this case, so this would be 100,000. So how many zeros are there? So there's 2, 4, so there's 1 left. So in this case, now remember, we don't know, they didn't tell us that how, of course they didn't tell us the half yearly payments. Now one thing that you must know, they say that 25 half yearly payments are made, so they actually gave us the number of payments. So that's one thing that I need you to know. I actually kind of made mistake the first time I looked at this. I actually thought that was actually 25 years, but not noting that this is actually 25 half yearly payments. Now since it is half yearly, we know that our interest in this case, so this is actually, the interest is actually 14% per annum compounded half yearly. So in this case, so we know of course the value of P to be 100,000. I hope that I didn't add those zeros, the 2, 4, actually I added 1. So of course we don't know the amount, so they say that what is the value of each payment if the interest is 14% per annum compounded half yearly. So in this case, what we're trying to get is that the half yearly payments that he must make. So we don't know that X value, but of course we know that the interest in this case, so this is actually 0.14 divide by 2, because it's half yearly, right? So of course the number of payments, they say that's how many payments, so that's 25 payments. Now again, we don't know that X value, so again, so this would actually be 1 minus 1 plus 0.14, what we divide that by 2. But how many payments did he make? He made 25 payments, so this would be minus 25, and of course we divide all of that by 0.14 divided by 2, and of course to get the value of X, so what you're going to do is you're just going to to plug this whole value in your calculator. So that would actually be the coefficient of X. So what you're going to do, you're going to take that value, and then the value that you're going to get, you divide that by that 100,000, and then you'd get that value of X. So in this case, so 100,000, so 1, 2, 3 would equals to so when you press this on your calculator, you would get, actually you'd get a value of 11.653583 and some other cents. So in this case, to get the X alone, what you would need to do in this case is to divide by 11.653 and those other cents. So in this case, to get the value of X, I'm just going to divide everything that of course that 100,000 by that 11.653. Of course, so in this case, what you're going to get the value of X being 8,800 and it's actually 581.5 cents. So actually, so he would need to make half yearly payments of 8,581 rand and 5 cents in order to to pay off that 100,000 if he wants to make 25 payments. So that would be, of course, the for that. So of course we're going to do the last question. So let me just pull up that. So of course question 3 says that Brian takes out a retirement annuity that will supplement his pension when he retires. In 30 years time, he estimates that he will need 2.5 million. Now listen to the terminology. They said that he will need 2.5 million. So this amount is actually the amount that is in the future. So in this case, so this we know that this is the value that is in the future. So they said that he will need that amount in his retirement fund at that stage. They say the interest rate he earns is 9% per annum compounded monthly. So they say that calculate his monthly payment into this fund if he starts paying immediately and makes his final payment in 30 years time. So in this case, we are trying to find out that how much must Brian invest in order for him to have 2.5 million at the end. So this actually is the future value annuity for this part. So in this case, of course, to find out how much he must invest in order for him to have 2.5 million in 30 years time. So in this case, actually use the future value annuity. So in this case, we know that the VF, I hope you still remember. So in this case, this will be X, of course, so that open bracket, 1 plus I for n minus 1. And of course, you divide everything by I. And of course, we know that the future value that he wants is 2.5 million, right? So we know that FV is 2.5, so that's 1 2 1 2 3, so that's 2.5 million. And we don't know, of course, the monthly payments, right? So that's what they are requiring us to calculate. So we don't know that, but we know that the interest rate that was 0.9, so that's 9% per annum compounded monthly. So this would be 0.09 divided by 12, since it's monthly. So we know that in a year would actually have in a year we have 12 months, right? So of course the number of payments in this case, so again, so in a year he would make 12 payments. So to find out how much payments he would make in of course in 30 years time, so what you're going to do, you're going to take 12 and you multiply that by 30, so to get the number of payments that Brian must pay, right? The number of payments rather. So this actually be 30 multiplied by 12, because in this case we know that he would make 12 payments in 1 year. So in 30 years he would need to make 30 multiplied by 12. So in this case, so this would be the number of years. So of course now we know that of course he needs to have 2.5 million, right? So this would be a 2.5, 1 2 3. So again, we don't know that X, so we leave that is open. So of course, so this would be 1 plus 0.09, divide that by 12. Of course, we know that the number of payments would be 30 multiplied by 12, but we subtract a 1. But now remember one thing that I forgot is that in this case, so of course they say that I think there was a word immediately somewhere. So they say Brian takes out a retirement annuity that will supplement his pension when he retires in 30 years time. He estimates that he will need 2.5 million in his retirement fund at that stage. The interest rate is that modern monthly. So of course they say they calculate the monthly payment into this fund if he starts paying immediately. So in this case, now remember we said if he starts immediately, you would actually raise that amount with the number of payments by 1, right? So in this case would actually need to add a 1 there. So they would actually need to add another 1 there. So of course we subtract the 1, and of course what you do, of course you divide that by the interest rate. So this will be 0.09. We divide that by 12. So again, what you're going to do, you're going to do the same thing. So you're going to put this value on your calculator. So that would actually be the coefficient of X, and then in this case you'd actually divide that of course by, you actually take this value, divide that by the value that you're going to get there to get the value of X. So of course if you do that, so of course if you put that value in your calculator, now remember we still have 2.5, right? Actually I'm just going to to go to the final answer. So in this case, what you're going to do, you're going to press this value on your calculator, and then you divide you take 2.5 million, you divide it by that value, in this case, to get that value of x. The same thing that we did on the last question. So in this case, you'd actually get x to be 1,354 rand and also 67 cents. So you would actually need to make equal payments, monthly payments of 1,354 rand and 67 cents in order for him to have 2.5 million in 30 years time in his of course pension fund. So the second question says now, so one thing that you needed to note was that you needed to raise that by one. Now remember we said, of course, if you start immediately, you would actually make an extra payment. So of course, if you didn't watch, if you of course didn't get this where I added the one, so you actually need to to go back to the video that I produced. So this was when we were looking at what happens, of course, if you start paying immediately, or of course if you miss few payments. So of course, so the second question, they say that the retirement fund does not pay out the 2.5 million when he retires. Instead, he will be paid monthly amounts for a period of 20 years, starting 1 month after his retirement. Now, one thing that you need to note, so in this case, that right now we have that 2.5, we achieved it. But in this case, so what the pension fund in this case will do is that what it will do is that you to pay equal monthly payments. So instead of him getting that 2.5 million, so what he wants to get equal payments, monthly payments in this case. Now remember, we have that value right now, but we don't know, for they say determine the monthly payments that he will receive. So we have this amount right now, but we want to know how much he will get every month, if of course that's his plan. So of course we know that this is the present value annuity. Now this is I included this this question because the other questions that I saw, they were only looking at loans. So I didn't want you of course to have this idea that when we are talking about the present value annuity, it only just resembles the only loans. So in this case, so if it's of course if it's a pension payout, it is also of course a present value annuity, because in this case you would have that amount, and of course what you would do is to try you'd get paid a certain amount of money, either monthly or semi-annually, in this case trying to reduce that amount that you have right now. So in this case, so this is a present value annuity. Remember we said that PV is actually equals to x, 1 minus, it's actually minus 1 plus I upon negative n, and of course we divide all of that by I. So again, we know the amount that we have right now. So this would be the present value annuity. So we have now, of course, we said that, so they said that of course the interest rate ends over the period is at 7% per annum compounded monthly. So of course, so what he wants is, so he would need, of course, he wants to get all of this amount for it to be 0 in 20 years time. So in this case, we know that PV in this case is at 2.5 million, and of course we don't know the monthly payment that you will get, but we know that of course the value, the interest rate in this case, that would be 0.07, but in this case they said compounded monthly, so we divide that by 12, and of course, so the number of payments, now remember they say that for a period of 20 years. So again, in 12 months he would have in 12 months he would be paid 12 payments. So in this case, so of course in 20 years you just take that 20, you multiply it by 12 to get the number of payments made. So in this case, so with the present value annuity, now remember we said of course there is a gap right between of course the day of course of the loan, if it's a loan, and the day that of course you pay the first payment. So of course, so in this case, so this will be 20 multiplied by 12. So in this case we have that to be 2.5 million. 1 2 3, so that's equals to x. We don't know that x again, so this will be 1 minus 1 plus 0.07, divide that by 12, but in this case to the power negative 20 multiplied by 12. And of course you divide that by the interest, which is 0.07, divide that by 12. And of course, to get the value of x, you're going to do the same thing. So you're going to take this, no, not actually, so you're going to treat this value here as actually the coefficient of x. And in this case, so what you do, you press that value in your calculator, and then of course when you get that value, you'd actually divide that, you'd actually take 2.5 million, you divide it by that value to get the value of x. So in this case, so you would get your x, the monthly payment being 19,382 rand and of course 47 cents. So in this case, so if he wants to finish all of that 2.5 million in 20 years time, he would need of course to draw 19,382 rand and 47 cents. So of course, so that's the end for today's lesson, unfortunately, and I apologize for making this video a very long video. So I have there are other few questions that of course, so there's question 4 and question 5. So I would kindly ask you, to try this out, and of course you can always just throw the answers in the comment section. So of course, if you have any questions that you would need to direct to me, you can always just throw them in the comment section. Of course, if you have any questions, you can always ask on the comment section. If you haven't subscribed, please be sure to subscribe and also hit the notification bell so that when the next video comes up, you'll be the first to be notified. And of course, so what I'm going to do in the next lesson, we're going to look at what happens if he decides to pay immediately. So if he wants to start his first payment in the day that he grants the loan. And also we'll look at what happens if of course you miss first few payments in this case. So that's what we are going to be looking at in the next lesson. So be sure to hit that notification bell so that when the next video comes up, you will be notified. So this is the end of today's lesson. It has been very fun doing this topic. I really enjoy this topic, but otherwise this is the end of today's lesson. So this is Sir Mike signing out. Sharp sharp.